across xi and xi square in Schrodinger. So xi indicates amplitude. Okay, often whenever you're talking about electron wave, so amplitude is indicated. Amplitude, what is amplitude? Whenever the wave is traveling, this is called amplitude, the height of crust or depth of crust. This distance. So in a particular electron, this distance is explained by, this amplitude is explained by xi. Whereas xi square describes a probability of finding electrons around the nucleus. Whenever you are taking nucleus, suppose I'm taking the orbital, this is the nucleus, around the nucleus where you can find the electron. So probability of, how much probability? Finding electron in space around the nucleus. This is xi square. That's the difference between them.
Okay, ma'am.
Okay, so this is wave function, nothing but. Okay, next. Ritesh Maharana, acetylation. Ritesh, are you there?
Yes, ma'am.
Okay. So acetylation. Acetyl, what's the name is indicating acetyl here? How acetate, you know acetic acid, right? What is the formula of acetic acid? CH3COOH. When 2 moles
Yes, yes,
of
ma'am.
acetic acid are combining, so here the water releases. Can you see here what is releasing water? So we have CH3COOCOH. This is left. This is called ketate. No, sorry. This is called acetic anhydride. That is formed by losing water molecule.
Okay, ma'am.
Okay, so this acetic anhydride is involved in this particular reaction. So here in this, to this you are adding a compound with OH and OH. Okay, so what happens here? So here CH, here oxygen OH left. Yes. So this OH is, this oxygen attacks the electron deficient site, which is called, why it is electron deficient is it is attached to oxygen. Oxygen is more electronegative atom. It attracts electrons from carbon, making it electron deficient. So as this become electron deficient, OH give electron. Okay, and this O becomes negative, O minus. So this O minus abstracts this proton here. Okay, with this what forms? COOH O C. So at last you will be getting OCOCH3. Carbon is attaching. So to the oxygen carbon, to this carbon COH it becomes, because bond is broken it becomes OH. Then CH3 already there. Then this total group, I'm writing it as OCOCH3. Okay, I'm writing like this.
Yes, ma'am.
So now what happens here? This oxygen donated electron, because of it, it got okay. Now it is stable because it loses hydrogen, which is the lone pair it is having. Now what happens? So this is the product which is formed. What can happen now? Any idea? Any clue? So this, see, whenever hydrogen is abstracted, definitely that hydrogen is going to lose. So this lone pair goes in, this hydrogen goes away, and this goes away. So that leads to formation of, so see here, OCOCH3 and hydrogen combines to form CH3OOH. Then you should know mechanisms, how to write the mechanisms. If you know writing mechanisms, then it is easy to solve. C double bond
Oh,
O
CA.
CH. This is product form. Okay.
Yes, ma'am.
Before answering Pratiti, Archana, do you have any questions? Preeti Singh, questions? Any questions? Text in the chat box. So C4H10O, this is the molecular formula. You don't know these there, H10O. So how can we write? There are four carbons, right? Pratiti?
Yes, ma'am.
They
Yes,
can be
ma'am.
in the straight line or they can be like this with OH, with OH. Or they can be, this OH can be attached to some position. This is first position. So they would be second position. This possibility is there. Next, all carbons can attached like C4.
Yes,
This
ma'am.
possibility is there. That's it, right? Four alcohol possibilities. Rather than that, nothing.
Yes,
Okay. Suppose if I'm taking this carbon, there are hydrogens. So what is chiral carbon? The carbon which is attached to four different groups like A, B, C, D. So here you can see two hydrogens are common. So no chiral carbon. Here again two hydrogens, not a chiral. Here OH is attached. Can you see here? This is CH3 group.
yes,
This is C2H5.
yes,
This is CH3 to the carbon. This H. So three
yes,
different groups you can find. So this is chiral. And here you can find all are
okay,
same
ma'am.
group. This is not chiral. Only one chiral carbon is possible. Is that correct?
Okay, okay, ma'am.
Is
Ma'am.
that correct?
Yes, sir, it is correct.
Okay. So higher alcohols, lower alcohols. Lower means like you can find molar mass difference or number of carbons difference. Higher alcohols are the one which are having more than two carbons.
Okay, ma'am.
Lower alcohols are the ones which are easily soluble. So less molar mass. So this of more molar mass,
Okay, ma'am.
high stability, like it takes into soluble. So you can write solubility decreases. Why decreases? Because of increasing molar mass increases. Okay.
Okay, ma'am.
And you can find in lower called existence of hydrogen bonding because of hydrogen bonding factor they are easily soluble in water like polar solvents. Clear?
Okay.
Okay.
Yes.
So next, Schwarz reaction. So this is the one which you have to remember, Schwarz reaction. In this, you have to, I said Ritesh many times that you have to remember what is reactant, product,
Product.
and reagent. That's it.
Reagent.
This you have to.
Yes, ma'am.
Yes, Preeti Singh, please. Yes, Preeti Singh. So in the reactants are alkyl chloride or alkyl bromide. So RCl or RBr. These are the reactions. Okay. So always in what's the reaction, the product
Yes.
is alkyl fluoride only. Why alkyl fluoride? You are taking chlorine or bromine, but how do you got fluorine here? Because you are adding some reagent which is having fluorine in it, like silver fluoride
Mm.
or HD mercurous fluoride
The
or tin fluoride. So these you
aluminum.
are adding. Okay, so you are taking heavy
Yes.
weight alkyl halide and you are making it into fluoride. Okay,
Yes, ma'am.
any other questions? Okay, next Chana question. Yes, Preeti Singh, please. Preeti Singh, you can speak out. Archana, are you there? Hello, Archana. Preeti Singh, you can text your question. Send your question in chat box.
Ma'am, rate of reaction.
What? Preeti Singh, please send your question in the chat box. Yes, Chana, asking for electrode potential here. You are there, right?
Yes, ma'am.
So there is a simple formula to find electrode potential. Electrode potential is equal to minus pH into 0.059. Okay, pH is given to you, right? So pH is not given, partial pressure is given. Okay, I'm sorry. It looks like electrode potential is equal to like E cell. E cell is equal to E naught cell minus 0.059 by n log. So here what we are doing, hydrogen electrode set in HCl solution. Okay. Is that complete question?
Yes, ma'am.
Okay. So minus log. So in what happens here? H2. Can you tell me what happens in this case? What is the reaction involved? H2 is formed from 2H plus 2 electrons are getting added. So H2 form. From this log becomes pressure of H2 by H plus. Okay, and this particularly when you are considering electrode, in case of hydrogen electrode, this becomes zero. So with this E cell is equal to minus 0.0591, and many electrons are involved here? 2 electrons.
Yes,
You see
ma'am.
here 2 electrons by 2 into log pressure is 1 atm by what is H plus concentration given? Or else you can take directly. So is any concentration of H plus given to you in the question?
No, ma'am.
You can consider 1 molar. What to count that? So no pH, anything is given to you. pH is given. So any pH value in the question.
No, ma'am.
I think they must give you H plus concentration, otherwise we cannot substitute anything. Please check the question again. Like 1 or 0.1 something.
1.0, ma'am.
That is KCl. pH is given.
No, ma'am.
Okay, H plus concentration is given. We use this. Okay, 1. So log 1 is 0. So what's the answer? Is it 0?
No, ma'am.
Log 1 is equal to 0. Something there is value here. At least they must have give pH 10 or pH 7 something.
No, ma'am.
So is it minus 0.8 to 7?
No, ma'am. Minus 0.414, ma'am.
Okay, okay. I'll tell you. So this is the maximum potential of hydrogen electrode and minimum is zero point 0 volt. This is minimum. Maximum is minus 0.827. But here the hydrogen electrode is set up in KCl, 1 molar KCl. Okay. So KC is
Okay.
what? Salt. So in case of salt, pH becomes 7. Okay. What pH becomes? 7.
Okay, ma'am.
So then it is half of it. So then in that case you will be getting electrode potential as minus 0.414 volt. Okay. By 2 exactly. The pH is 7 as it is salt. Initially it is HCl whose maximum is clear with the concept.
Yes, ma'am.
Okay. So Preeti Singh, you want rate of reaction? You need
Yes, ma'am.
example or else explanation. So rate, suppose like you are moving or your car is moving. So how you will check like the speed, right? The same thing for the reaction. We will be checking speed. The speed is nothing but called as rate. Rate of reaction is nothing but speed of reaction, like how much time it's taking to perform and what is the yield. Suppose I'm mixing, like suppose simply you're cooking food in your house. So in your home you're cooking food, like mm, so you are mixing, like suppose you take example of cooking the rice. So to get product takes certain time, right? So first to boil liquid it takes certain time, so with certain speed, and from boiling to becoming soft, tender, so it takes certain time. So it depends on the speed. So for every reaction, it can be any reaction, it can be chemical reaction or something. Okay. So this is called as speed of reaction. Okay, so suppose what we will do, we are going to take reactants. So you will mix all reactants together. After some time, you will find products, right? Initially, there are no products, but later on, products are formed. It means then what about the reactant? Reactants are going converted into products. So you tell that reactant concentration decreasing because reactants only are converted to product and product concentration increases when the reaction is happening. So how you will check the speed with respect to with respect to concentration per time. So change in concentration delta C time. Like for 10 minutes, the reactants are like something. So after 10 minutes, the reactants are utilized. They became, initially they are 100. So after some time, they became like 75. After some time, they became like 65, like this. So their concentration is increasing. And product, initially there is zero product, later on you will find one, two, some product number is increasing. So how you will express the rate of reaction? Rate of reaction is expressed in change in concentration over time. Like how you will check the speed of speed car, travel distance per time, in change in concentration per time. Clear?
Yes, ma'am. Clear है.
Okay. Next, please type your questions. Hyperconjugation, Archana. So hyperconjugation is nothing but this is due to the sigma bond. So mainly due to CH or CC bond. Okay, hyperconjugation is permanent effect. Hyperconjugation is permanent effect. You can find the electrons are moving or the sigma bonds are moving from CH bond or CC bond to unshared p orbitals. Okay, suppose this is the group which is present like H and H. So this is electron deficient, like it is a carbocation. Now what happens? This H plus can move here, or else this H plus. So this is the p orbital, right? Which is M. So this H plus can be transferred here. This particular permanent effect is called as hyperconjugation. Clear? So how this will happen means, so this double bond shifts here. So it becomes double bond. This single bond shift here and become double bond. And the bond between H and C is broken and it becomes C plus. Now there is one more possibility. What is that possibility? This bond can break to give. So now CH here plus H double bond C H H. So you can tell that sigma bonds of CH and C single bond are involving. Okay, with pi bond. This is called hyperconjugation. Clear?
Clear, ma'am.
So what is combustion, Preeti?
Yes, ma'am.
What is combustion? If anything is burning in air, burning in air is in presence of oxygen. So suppose you are like I'm taking something R. If you are burning in presence of air, that is oxygen, only in oxygen, this particular reaction is called as combustion. Like carbon plus oxygen, you are heating in presence of oxygen. It is called as combustion reaction. Okay. So when I'm taking R here R, I'm taking it as 1 mole. If 1 mole of R is burning with oxygen, okay, so in this burning process, you know that definitely when something is burned, heat is produced, right? So whatever the heat produced, that is called enthalpy of combustion. Understand what is enthalpy of combustion? It is defined as heat given out in burning 1 mole of substance in oxygen. Clear?
Yes, yes, ma'am. Clear है.